In this video, we will learn fundamental principle of counting and rule of sum. We will also solve some interesting questions of exercise 7.1 of NCERT textbook. And the first is fundamental principle of counting or fundamental principle of multiplication. If there are two kinds of pens on a shop, suppose this is pen 1 and this is pen 2, and there are three notebooks N1, N2 and N3, and a student wants to choose one pen and one notebook. In how many ways can he choose one pen and one notebook? He has two options for selection of pen. Either he will choose first pen or he will choose second pen. It means he can choose pen in two ways. Similarly, out of three notebooks, he can choose any one out of these three. It means he can choose notebook in three ways. Now, selection of one pen with one notebook. He can choose first pen with any one notebook. It means first pen and any notebook in three ways. Similarly, second pen and any one notebook again in three ways. So total number of ways is 3 plus 3 is 6. We can obtain this number by multiplying 2 and 3 equal to 6. So in general, if first event can take place in m ways and second event can take place in n ways, then both the events can take place in m into n ways. If number of ways for first event is n, number of ways for second event is equal to m. Therefore, number of ways for both the events equal n into m. It means if two events are taking place simultaneously or one after the other, then total number of ways for both the events is m into n. This is known as fundamental principle of counting or fundamental principle of multiplication. Second situation. Again, if there are two pens and three notebooks and a student wants to choose one pen or one notebook, then in how many ways can he choose? Either one pen or one notebook. Now the question is simple. In how many ways can he or she choose one object out of these five objects? Either one pen or one notebook. It means only one object out of five objects. So number of ways of choosing one pen or one notebook is obviously 5. And this 5 can be obtained by adding 2 and 3. So in general, if first event can take place in n ways, second event can take place in m ways, then any one out of these two can take place in m plus n ways. This time we will add these two options in m plus n ways. This is known as rule of sum. This is applicable if any one out of two is taking place at a time. If first and second both are taking place, then we will multiply the numbers. If either first or second is taking place, then we will add the numbers. Now, questions of exercise 7.1. First question of exercise 7.1. How many 3-digit numbers can be formed from the digits 1, 2, 3, 4 and 5? Total available digits 5. Assuming that, first part, repetition of digits is allowed. If repetition is allowed, how many 3-digit numbers can be made using these 5 digits? It means you are to make 3-digit numbers. It means you are to fill up these 3 boxes using these 5 digits. Now, one by one. In how many ways can we fill up first place? Obviously 5 ways. Any one out of these 5 digits can be used at first place. Similarly, as repetition is allowed, so second place can be filled in again 5 ways. Any one out of these 5. Similarly, third place can be filled in 5 ways. Any one out of these 5 digits. So, number of 3-digit numbers is first into second into third number, as we will fill up first place as well as second place as well as third place. First with second with third, so we will multiply these 3 numbers. Answer will be 125. Second part. Again, how many 3 numbers can be made if repetition of digits is not allowed? If repetition is not allowed, in how many ways can we fill up these 3 boxes? First place can be filled in 5 ways using 1 digit out of these 5. Now, repetition is not allowed, so you cannot use the same digit at second place. It means options available for second place is only 4. And in the same way, options available for third place is only 3, as repetition is not allowed. And in how many ways can we fill up all the 3 places? 5 into 4 into 3. So number of 3-digit numbers if repetition is not allowed equal 5 into 4 into 3, 60. Next, second question. How many 3-digit even numbers can be formed from the digits 1, 2, 3, 4, 5, 6 if digits can be repeated? So available digits 1, 2, 3, 4, 5 and 6. Yes. Repetition is allowed. How many 3-digit even numbers are possible? So to 3-digit and even. So again fill up these 3 boxes, but this time number should be even. How can we maintain even numbers? Extreme right place or ones place can be filled either by 2 or by 4 or by 6. This is the additional condition. Ones place must be filled by an even digit. So this place can be filled in 3 ways. Total available digits 6. Out of these 6, 1 has been used at this place. So remaining available options for next place will be 6 minus 1, 5. And remaining options for last place, it will be 4. Sorry. Repetition is allowed. Repetition is allowed. So second place can be filled in 6 ways. Any one out of 6 digits. repetition is allowed. Similarly, next place can be filled in 6 ways. So total number of numbers, this number into this number into this number. So number of even numbers equals 6 into 6 into 3, that is 108. Next is question number 4. Fourth question. How many 5-digit telephone numbers can be constructed using the digits 0 to 9? It means total available digits this time is 10, 0 to 9. If each number starts with 67 and no digit appears more than once. Okay. 5-digit telephone numbers, it means you have to fill up these 5 places. Start with 67. It means first digit must be 6, 7 digit must be 7. You have no option for these 2 places. Only one option for first place, only one option for second place. Remaining available places to fill up 3, and remaining available digits, as repetition is not allowed, so now available digits for next place is only 8 out of 10. 2 has been used. So, and similarly, next place can be filled in 7 ways and last place can be filled in 6 ways. So total number of numbers of this kind is equal to, so number of telephone numbers equal 8 into 7 into 6. This is your answer. Thank you.